Okay, solving rational equations, and again, rational equations are just equations that have rational expressions in them. Here you can see that we have 2x plus 1, or 2 over x plus 1. That's a rational expression, and it's in an equation. Okay, now there's a technique for solving these, and a lot of students are afraid of these problems, but really this technique will help you. It involves finding the least common denominator of all rational expressions in the equation. So in this problem here, our least common denominator, again, if you remember back to finding this, if I factor here, if I factor all of my denominators, we'll see here that I have x plus 1, and I have an x plus 1 and x minus 1. Okay? All of those need to be in my common denominator. So, if you think about it, our least common denominator here is x plus 1 times x minus 1. So that's the least common denominator of all rational expressions. Now, what I'm going to do is I'm going to use that least common denominator to eliminate all these rational expressions in this. So it's a technique using the least common denominator. Here's what we're going to do. We're going to take our problem here, 2 over x plus 1 minus 1 over x squared minus 1, and we're going to multiply that entire thing by my least common denominator, x plus 1, x minus 1. Okay? Now, you can't just do that to one side of an equation. You have to do it to the other also. So I'm going to multiply the 1 by x plus 1, x minus 1. Okay? So that's all we did. We multiplied both sides of the equation. Now, once we get that here, we need to distribute the least common denominator, this whole thing here, okay, to each one of these terms. So when I do that, here's what I get. I get 2 times x plus 1, x minus 1, all over x plus 1. That's the first term there, minus 1 times x plus 1, x minus 1, all over essentially x plus 1, x minus 1. That's what x squared minus 1 factors to. And all of that is going to equal x plus 1, x minus 1. Okay? Now, in doing that, let's see what occurs. Look at what you can do now. In each one of these expressions, if we look, we have a factor of x plus 1 in both the top and the bottom. So they'll cancel out. Same here. I have an x plus 1 and x plus 1, an x minus 1 and an x minus 1. So really what this technique does is, if you look at what happens after all the carnage, is eliminates all your fractions. Okay? Okay? Now, once you have that, this is a pretty simple problem. We just, I'm going to distribute the 2, so I get 2x minus 2 minus 1 equals x squared minus 1. It's the difference of squares. This is a quadratic. We've got to pull everything over to the same side. So if I add 1 to both sides, those cancel out. If I subtract 2x, I'll have an x squared minus a 2x. If I add 2, I get plus 2 equals 0. Okay? From there, this is a quadratic. I'm going to see if it factors. In this case, it doesn't. There's no two numbers that multiply to give me 2 and add up to give me negative 2. So I'm going to complete the square. Okay? Just to brush up on that skill. I'm going to subtract the 2 from both sides. I'm going to take half of negative 2, which is 1, and it's squared, and I'm going to add that to both sides. So I end up with negative 1 equals x minus 1 quantity squared. If I take the square root of both sides after that, okay, take the square root of both sides, I end up with x minus 1 equals plus or minus I. And then if I add 1 to both sides, I'll end up with x equals 1 plus or minus I. Okay? And that is your final answer on that one. Now, in this case, there are no real solutions, but we do have a complex solution. Alright. Next problem here. We want to do the same thing. What we need to do is identify our least common denominator here. We have a problem with fractions in it. And again, if we look, x squared minus 4 factors by the difference of squares to x minus 2, x plus 2. So my final common denominator is going to have an x in it. It's going to have an x minus 2 and an x plus 2. Okay? Leave yourself some room to work here. Alright, so we're going to multiply both sides of this equation by x times x minus 2, x plus 2. Okay? And, oops. When I do that to the left-hand side of the equation, here's the left-hand side of the equation. And again, you probably wouldn't write out these steps once you get real comfortable with this. Okay? It's kind of the nice thing about this, that you probably would not write out all these steps. Okay, x times x minus 2, x plus 2. Okay, because you realize that once you distribute this whole thing right here to each one of these, by the way, they're only multiplied to the numerator, you're going to see what you get. You're going to have an x minus 2, x plus 2, all of that over x minus 2 plus, same thing, x times x minus 2, x plus 2, all over x minus x times x minus 2, x plus 2, all over essentially x plus 2, x minus 2. And all of that is going to equal 0, because 0 times all of this junk up here is just going to end up being 0. Okay? So, now we got to look at what's left over after we distribute here. And this is this step right here that I'm working on right here. If you get this technique, you don't even really have to write this out. You'll just kind of get it. Here I have a factor of x minus 2 and a factor of x minus 2. An x and an x minus 2, x plus 2, all of those will end up canceling out, and I'm just left with x times x plus 2 plus x minus 2, x plus 2 minus x equals 0. Okay? And if I distribute all that stuff, I get x squared plus 2x plus x squared minus 4 minus x equals 0. And if you notice, this is really a quadratic. It's not simplified yet, but we end up with 2x squareds plus an x minus 4 equals 0. Okay? Now, if we look, we can check to see if this factors by multiplying 2 to negative 4, and that's negative 8, but there are no factors of negative 8 to add up to be 1x here. Okay, so this does not factor, and I'm going to go ahead and use quadratic formula, right? So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, and if we begin to simplify this, we get 1 plus or minus the square root of 33 all over 4, and honestly, you can leave it like that, negative 1 here, if your teacher wanted you to break it up, because we do that sometimes. If this is an imaginary number, you could break it up like this. That's it for rational equations. The only thing that you want to do at the end here is double check that x does not end up being something from the original equation that x could not equal. Remember, x in this case could not equal 0 or plus or minus 2. If you ended up with that for a solution, you would have to say no solutions. But in this case, this isn't one of those excluded values. Let's go right back up to the top real quick here. And just remember that here, at the beginning, x could not equal plus or minus 1, but we didn't end up with one of those as a solution. So we're good there. That's it.